Hello everyone, this is my JavaScript Tetris. It was not as difficult to make as I thought it would be, and I will give you a brief look into how I made it, starting with the interface, then the constants I used, and then the logic of the game. You will notice that it makes sense and it's not that complicated. This is the interface. I used grids for the layout, Google Fonts for the font, and everything is hard-coded as you can see, except the board. To create the board, you simply create a table element, and into that table you insert several rows, and into those rows you insert several cells. I included an ID for each cell, which I didn't use at the end, but that's all you need to do. And finally, append the table into the corresponding div. And then now to the variables and constants that we need. We need a two-dimensional array to represent the board. We have a state, self-played if it's in self-played mode, which I have not done. If the game is running, the score, how many lines, the next tetromino or the name of the figure, and the statistics. And now let's talk about the two-dimensional array that represents the board. I used the strings. There's many other ways to do it. Empty strings for the empty spaces, and characters representing the colors of the occupied spaces. And I use lowercase letters for those that are static, meaning they are already at the bottom, and the uppercase letters for the active tetromino, meaning the one that's in free fall. So we need a couple more constants for the program. For example, an array with the characters that represent the colors, for example, B for blue, O for orange, and so on. I used another one which is almost the same but has the name of the images for the figures. And finally, an array with objects representing the coordinates for each tetromino when it's placed at the top of the board. Okay, for the game to work, we need a couple of listeners so we know when the user presses a key at the keyboard. So we are adding the keydown event listener here, and also we want to know when the user clicks on a new game and in the future when they activate the self-played mode. Once we have that, we can move on to the game logic. Here is where I think things will make sense. So whenever the user clicks on a new game, what we will need to do is stop any previous games. We will look into the interval in a little bit. We will hide the game over signal or pop-up. We have to reset all the statistics to 0. We will create a new board. We will select a new randomized tetromino, and we will place that tetromino into the board. We will increase the statistics with that new tetromino so that it's displayed from the beginning. We will select the next tetromino. Here just places some debris at the bottom. We can remove that if we want. We will set the running state to true because the game is running. And we will finally render the board. We will look into the render board later on. because it will convert an array from this into this. It only inserts an image. That was the initialization of the game. And now into the interval. As you know, the interval will execute this code every few milliseconds. So the game flow is this. If the game is running, we will check if there's an active tetromino, meaning that there's a figure in free fall. If that's the case, we will lower it one place. So that's pretty simple. If there's no active tetromino, um, we want to check if we can place a new tetromino, because if a new tetromino cannot be placed, it means the game is over because everything is overcrowded. So we will display the game over pop-up and we will stop the game. But if we can get a new tetromino, we will add a new tetromino. We will increase the statistics for the tetrominos, of course, and we will select the next tetromino using random tetromino. And we will increase the score. I'm giving 1 point per new tetromino placed in the board. And finally, after the end of the turn, we want to know if there are completed lines, so we can increase the score. This method gives 10 points per line, and we also increase the lines statistic. We finally render the board so that we can see what happened into the board array. And this is a clear interval just in case, so that if the game is not running, it also stops. And to the end with the game logic, we need the user to be able to interact with the game. And here, at first glance, you will see that it is very simple logic, because if the game is running, whenever the left key is pressed, we will move the tetromino to the left. If the right, we will move it to the right. If the up key is pressed, we will rotate the tetromino. This was a little tricky. Yeah, but if the user presses the down key, we will drop the tetromino. This was the trickiest part, I think, the drop method. And when we drop a piece, of course, we want to know if there were completed lines, so we can increase the score and the lines statistics. And finally, we render the board once more. With that, we have finished the game logic. And to keep the video short, I will give you a glimpse of the methods or functions that I have created in a separate file I called lib. It's kind of a separation of concerns. That's where all the functions like move left, rotate, and render board live. So let's move into that. For example, this is what the function render board does. First, we want to know if there's a completed line, and this is a simple function. You want to check a complete row if it's filled with characters, so that means it's a complete line. So we will want to clear that line and move everything down one place, one location. And the next, we will want to check every square, clear it, and if the board has a character, meaning it's not empty, we will want to place an image in that location so that we can see a figure there. And finally, we will want to update the state and statistics and the scores. And now let's see the move left and the move right functions. And they are very simple. We only have to validate if the piece can move to the left or the right. We just have to check if, in this case, to the left, that means -1 position. It's not occupied or it's within boundaries. And if we can move, we only have to do board data in the -1 position will equal to the board data into this position, so that square by square we move all the parts of the tetromino to the left. And moving to the right, it's pretty much the same, except instead of -1, it's +1. Uh, I guess I could have done just one function and just somehow change the operation there because they are almost identical, but I didn't because there's slight differences into the boundaries. Now let's check at the rotate function. This was a little trickier for me, but in the end it was not that complicated. So let's see. First we want to get a mini board. It's what it's the array that encapsulates the active tetromino, and we will try to rotate that. So the trick here is that the inward 4 or the nested 4 will go into the outward index of the array, so that we will be inverting columns into rows, and we are starting from the bottom, as you can see here. So it will make this conversion, as you can see. And after we have rotated the mini board or the active tetromino, we want to know if it's not in occupied space and if it's within boundaries. If all that works out, we will want to return the information into our board data. Okay, let's leave the drop function out of this video. It was a little more complicated than the rotate function, but you have the idea so far. So we are just moving the active tetromino all the way to the bottom and see how far we can place it within boundaries, and checking that it doesn't overlap with any other static tetrominos. So I think that's all. Of course, if you want to check all the code for yourselves, you can visit my GitHub repo and also GitHub pages if you want to test the game yourselves. It works, as you can see. I think there's a couple of exceptions, but they don't prevent the game from working. So I haven't checked into those just yet. And maybe later on I will program the self-played part. So I will try to make an algorithm that plays itself. I have done this with the Minesweeper game. I coded a Minesweeper, and then I made an algorithm that solves it because it looks cool. I will leave the link to that video in the description as well. So that's all for now. See you